Environmental studies fall under the umbrella science of earth science. So what do we mean when we say earth science? Well, we're specifically talking about the questions we ask, the tests we run, and the way that we study the natural phenomena in our world. This is big and complicated because our planet is big and complicated. But because we're human, we have categorized, sorted, and defined all of the things that we observe into 4 spheres that make things a bit more manageable. So when we ask questions about what we experience in the world, we can know which sphere or spheres to start looking at to answer that question. So what are the spheres? Well, they're pretty intuitive, and they divide our planet into the solid Earth, the liquid Earth, the gaseous Earth, and the living Earth. For example, the geosphere is generally studied by geoscientists like geologists, geoengineers, geochemists, petrologists, mineralogists, etc. And all of these people study the solid parts of the Earth and all of the bits of our planet that are under the crust, even if they're not exactly solid. A lot of geoscientists get into the interactions of the geosphere with the hydrosphere and the atmosphere and the biosphere. Now, I'm a paleontologist, so I study the interactions of the geosphere with the biosphere specifically. And these in-between places and the interactions between spheres are really cool and really interesting. And it's what makes Earth so cool and interesting. We're a bunch of scientists from a bunch of different disciplines, all helping each other untangle the complexities of our world by working together to answer big questions. The geosphere. This is where I'm most at home. The geosphere is the most beautiful of the spheres, in my humble opinion, and it includes the solid parts of the Earth, like breathtaking mountain ranges, majestic and terrible volcanoes, tropical islands, exciting geysers, and sparkly gems, rocks, and precious metals. It is truly wonderful. But to get onto the topic, geologists help answer questions in earth science that have to do with topography, natural disasters like earthquakes, volcanic eruptions and landslides, groundwater, soil, mineral resources, past events, past trends, carbon sequestration, and so much more. One of the big benefits of the geosphere is that all of the evidence held in the solid Earth lasts for hundreds of thousands to billions of years, depending. And this helps give us really long time spans to study and helps us more accurately predict future phenomena because the data sets can be huge. Okay, so arguably the most complex of the Earth's spheres is the biosphere. This is the living Earth. It encompasses everything from tiny viruses and the components of the basic building blocks of life, like DNA and RNA, to entire organisms, behaviors, populations, and communities. Biologists like geneticists, zoologists, population biologists, herpetologists, psychologists help us answer questions about population dynamics, the lifespans of viruses and diseases in the tissues of plants and animals, conservation of species, ecosystems, and how they affect life, trends in the evolution of species and communities and populations and interactions between those communities, and even how we as humans think and act on big environmental issues like climate change. Scientists studying the biosphere bring some of the most relatable parts of our world into greater context of the planet, and we rely on this for our continued existence. Okay, the hydrosphere. The hydrosphere encompasses the largest portion of the surface of our planet, which includes the oceans, rivers, lakes, seas, ponds, and really anywhere there's a collection of water molecules. Now, since most of the water on Earth is salt water in the ocean, there's a lot of focus on studying the ocean. But fresh water is vitally important to humans, and so we have a large body of research devoted to that specific resource. Scientists that study freshwater tend to be chemists, geologists, hydrologists, while studying the ocean is often the work of oceanographers. Now, hydrologists and hydrogeologists study the chemical and physical characteristics of rivers, streams, deltas, groundwater, and even how human settlements and technology like dams affect those freshwater sources. Now, oceanographers like hydrologists like to study how salts and minerals and gases mix with the water and change the chemistry of the aqueous, which is a fancy way to say the mixture of water and other stuff, this aqueous system. The chemistry of the ocean affects basically everything on Earth. The chemistry of our ocean determines how oceans circulate, what can live where, how high the sea level is, and even how hot our atmosphere is. Now, that's because the ocean holds a lot of the excess carbon that ends up in our atmosphere, which leads to acidification, coral bleaching, and dead zones. And the ocean has a lot of thermal inertia, which means that it holds a lot of our planet's heat and it holds it for a really long time. So even after the atmosphere cools, the ocean keeps things warm for decades. Arguably, the oceans are the most important part of our planet and what makes our planet so unique. A small change in the ocean leads to large changes in all of the other spheres. Last, but certainly not least, we need to talk about the atmosphere. This is the gaseous part of our planet that involves all the layers of protection our planet has from the cold, vast emptiness of space. Climatologists, meteorologists, atmospheric physicists, and atmospheric scientists in general study everything from greenhouse gases and how they change the chemistry of our atmosphere to circulation of different temperatures, jet streams, weather, hurricanes, and how each layer of our atmosphere is unique and contributes to the whole system. Now, the most pressing issue facing Earth scientists today does have to do with our climate. We know without a doubt that our climate is changing too quickly for the other spheres' systems to keep up with. And we know that this is going to affect us and this remarkable planet that we inhabit. The takeaway message of this video is that yes, we do divide our Earth into different spheres, but those spheres are a human invention. The divisions are really arbitrary. There are more interactions between the spheres than there are phenomena that are encompassed by a single sphere. Our climate is definitely atmospheric, but it changes depending on the physical characteristics of the ocean, the behavior and makeup of biological population, and the cycling of geological resources. Everything on our planet is connected. Even you, sitting in front of your computer, you are interacting with all four spheres as you're watching this video. You're biological and the result of evolution, and you are breathing air and enjoying an environment that isn't freezing or scorching, and you're using energy from fossil fuels to power your computer. And while we're at it, a computer is really just a special kind of rock that we have tricked into thinking for us. And if you're interested in that, you should take my Geology 101 class. So really, Earth science is just the study of the interactions between different spheres and the systems that those interactions create. Now keep this in mind as we move through the rest of the class. We're going to be looking at details from each of the spheres, but the only reason we need those details is to understand the system and the interactions that they contribute to.